In programming, we have a common data structure called stack, which resembles a stack of items in the real world. Imagine you have a stack of books. The last book that you put on top of this stack is the first book that you can remove. We refer to this behavior as LIFO, which is short for last in, first out. So this is a stack data structure, and it's very common in real-world applications. A good example of that is your browser. Whenever you navigate to a new website, your browser keeps your browsing session in a stack. So when you click the back button, it takes you to the previous website. Let me show you how it works. So we start with an empty stack. Now let's say we navigate to website number 1. Now here for simplicity, I'm using a number. If you're building a browser, instead of a number, we'll use a string, which is the address of the current website. Now let's say we navigate to a couple more websites and then click the back button. At this point, the browser removes the item on top of the stack, and then it will redirect us to the previous website. Now let's say we press the back button a couple more times, so we'll end up with an empty stack. At this point, the browser will disable the back button. This is how a stack works. Last in, first out. Now let me show you how to use a stack in Python. Basically, we can use a list object as a stack. So here I'm going to define a variable like browsing session and set it to an empty list. Now let's say the user navigates to website number 1. So we call browsing session.append method and add the address of the current website. Now let's say the user navigates to website number 2 and then 3. Let's have a look at what we have in our stack. So we print it, and as you see, we have a list of 3 items. Now, when the user presses the back button, we should remove the last item in this list, right? How do we do it? We use the pop method. So we call browsing session.pop. This will remove the last item from the stack and return it. So we can get it here. But in this case, we're not going to use this value. Let me just print it on the terminal. So you can see that. So 3 is removed from the stack. Now, if we print our stack one more time, print browsing session, you can see 3 is removed and we have only 2 items in our stack. So we need to take the user to the previous website, which is the item on top of the stack. And we can get that using a -1 index. Very easy. So back here, browsing session of -1. This returns the last item. So we print it. And I would like to add just a label for clarity, redirect. Let's look at the result. So when the user presses the back button, we redirect them to the previous website, which is website number 2. Now, and we can get that using a -1 index. So when we apply the not operator to an empty list, we'll get the Boolean true. So to see if our stack is empty, we can simply write code like this. If not browsing session, then at this point, we will disable the back button. So let me recap. We use the append method
Wow, I just realized my microphone was not on this entire time. It doesn't matter. No one's watching this. And shooting it. Uh, God. Anything else? Not other than like X. Run this. Okay. Well, we'll see if it actually works on our test case. I got zero P. Aha! Aha! I get it. Right? So we filter it out. Alright. Put this actually in now. Okay. So I understand why. Because the first thing we're doing, right, is we are like filtering it. So it comes out as P, right? It's not a palindrome. I see. This could be a very cheesy. I think I did the same thing. I think I did the exact same thing. Mine's so slow, 300 milliseconds to see like the actual answer we're supposed to get. Um, okay. I'm not gonna ask questions. Okay, so here he is lowering everything. He has an index, he has the max, he has the result, IIJJ, while this, if not, is all no. What the hell is alnumerical? Alphanumeric. Did they say that in their question? Oh, there's a whole function for that. It's actually smart. I plus one. It's not minus one. No clue what those two are. We're gonna try this problem. Knows this. Alright. Over here we have we're designing a stack that supports the push, pop, top, and get minimum operations. So, we're building an actual object. I forgot how classes work. Um, let's really think about it, okay? Let's really think about it. What is that one website called? Think about it. Mm, it's something. It's Calidraw. So every single object, right? Like I have to think of it like this, right? So you got like so we can name it, right? But it doesn't really matter. Let's actually read the problem properly. Design a stack that class or supports push, pop, the top function, and then get minimum function. So minimum min stack initializes stack object. Okay. So void push so this into val pushes the element val onto the stack. We got pop, we get top element, and we get the minimum element in the stack. Okay, this shouldn't be hard. This is actually not gonna be hard, but I just want to like visualize, you know what I'm saying? So it's gonna be like right? It's gonna be a list. So hmm. Let me see a video just so I can like, you know what I'm saying? Linked list. I think we're gonna have to call it class or make an object. I want to see the how
Well,
you
what's
actually because I remember
in this?
this video was really helpful understanding this.
We'll be passing in a data point or an element to be stored by this node in the constructor. Um,
Okay, so min stack equals new min stack.
and by default, it'll be set to none.
Delta. So yeah.
So this is where we're going to be storing the past data point, and this is where we'll be storing the pointer to the next node. As you can see in the constructor, we're initializing this to none, which makes sense if you recall that the last element in the linked list is always going to have its next pointer set to none. So by default, we'll set it to that, and then if we have a child node be attached to the end of this node, we'll then update. Here is just have a small once again because
So it's gonna have itself, and we can define what the function does. Okay, so yeah, I don't even need Scally Draw, just a fake, right? So we're gonna have values. So we're gonna say stack goes in stack self right now because we can have an empty list, right? So when we're pushing something to the stack, how does bro? It's like class objects. Yeah, it's something. This is a linked list, which has nothing to do with what I'm doing. I'm just trying to like visualize. It's not really helping. maybe I'm overthinking it, right? So we're gonna have some data, right? We're gonna start off with nothing. Um, but it definitely will be, you know,
Object of the class node length, as we've seen. To our command prompt and run the file. Okay, so as we expected, obviously at this point we have nothing in the list. For now,
so initializes it.
and then here, once we're done, set a new variable for our current node we're looking at. Set that equal to head. And then we're going to begin traversing over the nodes.
Aha, ha, ha. I still don't get it. So we create a new thing. We could push a value. We could push another value, push another value. And if we get the minimum, we know that's going to be 0. Pop the last value, which is going to be 0. And we can top the new value, which should return top. Gets top element in the stack. Pushing 1. And pushing 2. 0. What? Why does it get 2? Does it get the largest number? Gets the top element. So I'm assuming literally the biggest element. And get the minimum. Oh, because we popped 0. It is actually the top element. Okay. So we have data within them, and right now we have nothing. Then, if we want to push something, so if we're pushing something, we're basically doing. Just do, you know. Or I could just say just yes. What the heck am I supposed to do? I just locked in so hard. I zoned in. Alright, so there's one case. It's this. Okay. I'm just gonna keep note of these commands, right? I'm just gonna say stack. I want to debug, but I kind of want to grad pragmatically. Sorry. So I'm gonna go here. I'm gonna do Python daily.py. Right? How to record. Trying to repo this. Repo. I want to like live experiment. Um, so we could do stack. Push. Push. Then you want to get the next stack. Then it's gonna pop it, stack, pop. Then he's gonna stack pop values. Then he's gonna stack. I'm not sure what the mistake is. Yeah, like we return zero, like 0 to 1, 0 to 1. Like I'm returning them. I don't want to check the solution. I think I'm doing it right, but at the same time, does he like want me to like? So you want me? Oh, oh. I might understand what they mean. I might. Yeah, if that's the case, it's really weird. So we're gonna self that out, but maybe put this right. Self that output is just gonna be. Okay, all I'm doing, not really. It's gonna be outputs. So every single time I do this, I'm assuming I'm self dot. I do need to return. Like what? Okay, let's genuinely try this one. I actually do not understand. Oh. Oh. So top, you just want me to return, like, you just really just want me to return this. You get many, you just want me to return it. This is the reason I might crash out. Auto pops, crash out. This was such an easy problem. I did not need to spend that much time. Whoa, I am not ready for a hard. Chill. Reverse polish notation. Generate parentheses sounds very interesting. Okay. Um, pick one or two. Random. C's. So you were given an integer n. Return all well-formed parentheses. What? So return all well-formed. You are given an integer n. So n, boom, 3. Oh, I get it. The different possibilities. That is so weird. That is very weird. I'm supposed to use stacks here. Interesting. Yeah, this is definitely not gonna be easy. Return all well parentheses strings that you can generate and pairs of parentheses. This is actually interesting. Um, Writing this back up. Yeah. So they give us, let's say we have n is equal to 2. So realistically, you only have these two options, right? You do black like the back, or you do like back and inside again, you do like that. Which I think is literally what it did. Like over here is everything centered. Over here it's like we're gonna put you in a circle with two other ones. And over here they're like, you know what I'm saying? We're just gonna do 1, 2 over here. 1, 2, 3. 1, 2. 1, 2, 3. 2. Oh, this is gonna be headache, 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 headache. So how the heck do you stack this? Oh, I don't even know. You're supposed to generate all possibilities. Constraints are 1 to 7. I don't even know. I don't even know. Um, I don't want to give up. 3, 2, 3, 2, 2. Like I get it. Like all of them are enclosed into one. Then you have one enclosing two. You got one enclosing one on one side. You got one enclosing the other one outside, and you got each of them on their own. How are stacks used in this? No clue. So there's only one possibility. So I'm supposed to generate. Wait, you were given a parenthesis to return all well-formed parenthesis strings that you can generate with. So I guess we have a list of possibilities. So So parentheses. So LR is gonna be equal to LP. This parentheses is gonna be just this list, right? And let's say we have 1, right? So we can say while every single n, so while, I don't know. I know what, like, you have 1 over here, 2. So as long as, because you can have, like, you can have literally, you can do it as much as you want. Let's say just 4, right? I could do 1, 2, 3, 4. I could do 1, 2, 2, that, and then I could do another one like this. It's very weird. I can't. I don't want to think that much. Shall be honest. I'm not gonna cheat. I'm gonna just leave it at this for today, honestly. I'll make sure I solve the. I'm not gonna check the answer. I'm not gonna check the answer. Tomorrow I'm gonna come back. I thought about it, right? I actually want to solve the problem because I know it's not that hard, but once I understand, like, I'm gonna see life in a different way. That's just how it works. But you guys, I'm gonna see you guys tomorrow.